Hosting provided by Host Tornado. They offer website hosting packages, dedicated servers, and VPS solutions. Host.t.net.
Programming Throwdown, Episode 11, Lisp. So I've started the new job out here in California, and people are so much healthier out here. It's a little depressing, I'm not gonna lie.
Yeah, I think I'm kind of trying to wane you down, but it's only a matter wear you down, but it's only a matter of time before you'll be playing ultimate frisbee and
Yes.
and going cross country running and all that stuff.
So my cube mate, the person who works in the cubicle with me, has one of these standing desks.
Oh yeah, mine does too.
So she actually stands up the entire day. She has a chair, but I don't think I've ever seen her use it. And,
oh really? See, the guy who sits next to me, he has a weird chair. Like when he does have to sit or want to sit, his chair is such that he like sits on his shins, kinda. Like he's like, yeah, because his desk is high, right? So you can't use a regular chair. So he has this weird chair where his knees bend like only a little bit, and you kind of, it's more of like a leaning than a sitting. But yeah,
like
he has a stand-up desk.
Or something? I don't know. This sounds weird.
Oh man, I don't know how to describe it. But yeah, he stands all day too. It's pretty nuts.
Yeah.
So did you get a standing desk?
No, I've actually been thinking about it because my desk is kind of low and I'm kind of tall. And so I was like, maybe I should get a standing desk and then like a chair that's just really high, like a bar chair or whatever. And I was thinking that would be pretty nice because sometimes I would like to stand up and stretch while, working. So I've made a compromise and I got an exercise ball, like a big exercise ball. And I sit on that. And the idea being that, you can kind of bounce around and you have to keep yourself stable. But I'm having to work up to it. So the first time I sat into it kind of too long and my back was killing me. So now
I did the same thing.
Did you?
Yeah, I sat on it, and I was like, I'm gonna try this out because there's one in our cube, and after about halfway through the day, around 3 or 4 in the afternoon, my back started really hurting and I couldn't figure out why. And I was like, God, it's just back pain. I don't understand. And I was like, wait a minute, it's this freaking ball.
Yeah, I didn't even last
a day.
Yeah. So now I'm working my way up. So I've slowly been sitting more and more. So I think today I sat, probably 3 or 4 hours on it and did okay.
Nice.
I'm not tired or sore or anything. And I'm trying to, so that's one of my things. And I work on the 4th floor, so I've been taking the stairs up and down. I think I've only ridden the elevator twice the whole time I've been there.
Oh, nice. That's really good.
So that's part of my, try to do better routine because I'm not playing super extreme exercise frisbee with you.
Yes, frisbee. So I just I found at our work they have sort of like a jungle gym for adults.
What?
That they had just built. Yeah, this is pretty crazy. So they have that climbing rope. Did you ever have that when you were in middle school? It's just like a huge rope.
No, but I know what you're talking about. Yeah.
Yeah, you have to kind of use your arms. They have one of those, but it's made of plastic fiber instead of wool, and so it gives you the worst rug burn. So I tried it for the first time. Yeah, and I got about halfway up the rope and I gave in. And when I was coming down, my hands, they just got all tore up from
And
this
then all
rope.
the jocks laughed at you?
Yeah, that's right. I got beat up even at work. It's sad. High school memories all over again. They stuffed me in a trash can. It wasn't pretty. But they have those things that, have you seen these? They're like tables. They look like tables, but they're anchored into the ground. And you have to sort of jump onto the table, but it's really high. It's like twice the height of a coffee table. They actually have different sizes, but the one I was on was like that. Mm-hmm. And so just from standing still, you have to jump onto this table and then jump off and then keep going back and forth. And they had a whole bunch of different, they had a little demo day and I went to it and they had little routines that you should do to get, more fit and stuff like that. But being fit is definitely huge over here in California.
Yes, it is. And I'm failing at it, so my goal is to improve slightly so I can feel better about myself.
Yeah, it's let's get all the nerds in one place and then try and teach them to exercise.
Yes. And they put a few non-nerd people in just to make the nerds feel bad.
Yeah, that's right. Let me show you how it's really done if you weren't a nerd.
On to programming news.
Yeah, speaking of exercising, let's exercise our processors with
Wow.
running Cuda natively on the CPU.
Yeah, yeah. So I know you've done this a little, and I've done some of this, but there's the new one of the new things that's come out recently is the programming, general purpose programming of graphics processing units. So the things that are in your computers, pretty much all the computers nowadays, to some extent, to run your graphics and accelerate anything doing with drawing to the screen, with 3D rendering, like for games, and all that's handled by these GPUs, which the basically come down to many cores, small, lightweight processing cores that are able to do tons of tasks in parallel. For instance, when you have to figure out where a triangle should show up on the screen, there's maybe millions and millions of triangles in a given frame of a game. And so you can do all of those calculations in parallel. And so these graphics processing units have gotten really, really good at doing things in parallel. And probably
Yeah,
the
for sure.
most so I don't know. So ATI and NVIDIA are the two big graphics processing people, and so
Well,
they each.
ATI got bought by
Uh,
AMD. But
okay.
yeah,
So AMD and NVIDIA, and Intel's now starting to do. Well, both of them now are starting to even Intel and AMD are starting to do interesting things with putting CPUs on or GPUs on the CPUs directly and putting really high bandwidth connections between them. So
yep.
that's kind of interesting. But NVIDIA has a language that you use to do this general purpose programming for GPUs, and AMD has their own as well. But NVIDIA's is called Cuda, and it's a kind of a dialect of C, which is limited. You can't do a lot of the same things you might be able to do in regular C or C++, but for the most part, it's just a C program, and it runs, maybe thousands or hundreds of thousands of threads, and each one just does a little task, so massively parallel. And
Yep.
that's really good for certain operations like image processing operations, graphics operations, certain kinds of like simulations, like Monte Carlo simulations, where you choose random numbers and run a little simulation based on that random number. Things like that can be really good. The problem is that the code between what you write for a CPU and what you write for a GPU are so very different from each other. It can almost make the expense of going through creating a separate code base for your CUDA programs, unless you're one of these few cases that get 1,000x speed up from it. It almost makes that not worth it, and it's better just to buy or pay more to get the latest and greatest CPU so that you can just have one code base. And
Yeah, and the other part of it too is, the GPU, you have to communicate with it. It's sort of like an external processor. Whereas the CPU, it's right on board. And so because of that, debugging is much easier on the CPU. Like you could take a
yes,
program that's running and just stop it and say, all right, right now, what's the state of the system? Now let's process one instruction. Now where are we at? But, because you have this GPU on a completely different card, the debugging becomes much more difficult. You can't do the kind of cool, hacky things that you can do, that debuggers do for a CPU.
right. Oh, and the other thing is that the pipe between the CPU and GPU, the PCI Express bus, is limited in its speed. You think it's really fast, but it's really not all that fast.
Yep.
So there's all this overhead of sending data to the GPU to get processed and getting your results back. And so there's a crossover point where when your data gets big enough and parallel enough, it's worth it to send it there and get it back. It's faster. But below that threshold, it's better to do it on the CPU. But if your program has dynamic, size of data, you kind of either have to have code in both and choose on your own which one to run, or you just got to pick one or the other and suffer non-optimal cases. But what would be ideal is if you could write, for instance, just CUDA code. Well, ideal would be just write C or C++ code and have CUDA automatically do all of this for you would be awesome.
Hmm.
But short of that, if you could write CUDA code that when you're below a certain size limit, the overhead's too much, and so you go ahead and just run that on your CPU, or in some case where the GPU isn't available, so for portability reasons, to be able to run the CUDA code native on just the regular processor, the CPU, would be
Yep.
a big advantage.
or when you're doing development and you
Debugging.
want to,
Yeah.
yeah, run it on the CPU once and make sure it works, and then run it on the GPU the rest of the time.
Yeah, so that all those cases are really important cases, and um, it has not been something that was the first priority because they wanted to get this working right first. But now it looks like some other people are making progress in being able to compile CUDA code down to run on x86 to enable this kind of thing to take place. So it is kind of an interesting article. Hopefully, we'll see more of this in the future because it could be a big boon to the widespread use of these GPU processing paradigms.
Yeah, yeah, definitely. Yeah, I think it's awesome. So a lot of people kind of write us and they say, "Oh, I really like making video games," or I think somebody sent us an email a little while ago and they were using, I think, Visual Basic to write video games, and
That
games
was
seem to
me.
be it's you masquerading as somebody else. Aw. But they, a lot of people get into computers because of games. I mean, I love games. That's one of the reasons why I got into
Hmm.
computers. A lot of my friends have said, "Oh, the reason why I got into computer programming is because I wanted to make games." And of course, making games is really, really hard. There's a lot to it, and often it's done by teams of people. Back in the day, when the games were on Atari and there was like 4-bit graphics, one guy would make a whole game. But nowadays, most games are made by teams of hundreds of people. However, there's still a community of people who are just single developers or small teams making games, and one of the more popular communities is called the roguelike community. So a roguelike is essentially it's a game derived from Rogue, which is a ASCII game made I think in the 70s. But the idea is it's ASCII art. So you're a little at sign and you move around on the screen, and the screen's made up of little period signs for the floors and for the floor tiles, and little like the little pipe symbol and the minus sign for the walls and things like that. And so the graphics are simple, the gameplay is often quite simple. Sorry. The
Uh,
mechanics, the mechanics and the visualization, the GUI is simple, but the gameplay can become very complex, and so people can
and it's
do
typically
really
brutally
interesting
hard.
things. Yeah, there's often brutally hard, or just the games are incredibly complex. Like Dwarf Fortress is one of the more popular roguelikes, and you actually you manage a civilization, and this guy implemented an economy that kicks in.
Mhm.
You have a king, and you have to have these nobles that have to be managed. There's an entire water system which the creator of Minecraft kind of lifted, and so now you can find it in Minecraft. But at the time, Dwarf Fortress was the only game that had that kind of fluid dynamic system. It had the 3D. It has a 3D, environment where you can destroy any of the blocks, kind of like Minecraft.
Mhm.
So it was the Dwarf Fortress is and continues to be, an inspiration for many other games. And Tarn Adams, the creator of Dwarf Fortress, received a ton of notoriety. And I know of several roguelike developers who got job offers from game companies just because of their involvement in roguelikes. So for people who want to make video games, this is a great way to get into it. Is to make a roguelike. And for people who want to do that, there is this website, which is how to write a roguelike in 15 steps. At one point, it was a while ago, but I don't even remember when. But at some point, I went through these 15 steps and made a
Oh yeah.
roguelike. And yeah, and it's really rewarding because at the end, you have a finished product, and you've also learned a ton. Um, you've learned about when do I create new classes versus when do I make things data driven. So for example, when I started, I had a sword class, and then I had a flaming sword class and an ice sword class, like they're all .cpp files. And I had just all this code and no data. And I realized, I don't need all this code. All I need is just an weapon class, and then I can have a little string which tells me if it's a sword or an axe or whatever. So I mean, that was a valuable lesson as a programmer, is how to make the code data driven. And I could go on and on about all the things that I learned from these 15 steps, but it's really useful. And for any kids out there who want to start making their own
Or
video
adults.
games, it's a great way to start. Yeah, or adults.
Yeah, now you're encouraging me to feel like I should go do this in addition to sitting on my exercise ball all day.
Yeah, maybe you make a roguelike where the character is on an exercise ball.
Or he's in an exercise ball, like a giant hamster ball.
Oh yeah, like maybe if you go forward, like if you go to the left too many times, the momentum of the ball
Or
like
keeps
keeps
going.
moving you
Oh,
forward.
man.
Yeah, that could be tough.
So to tie in the steps, it takes you 15 steps to make a roguelike, but I can have you become a good programmer in just 6.
Wow, six. They must be pretty tough steps.
So the title of this article is actually "Become a Good Programmer in 6 Really Hard Steps," and it's kind of funny because the author of the article actually says that the 6 steps should take about 10 years or more. Oh, I'm sorry.
Nice.
Actually, I think the first 5 steps take 10 years, and then
Oh,
step
okay.
6 begins at the 10th year and can take possibly forever. And it's a little tongue in cheek, but it's kind of good to go through, and it really does in the same line that you're talking about, learning to program games and teaching you programming because of that. This guy just kind of goes through the phases that people tend to go through, and therefore if you're trying to go through it or wanting to go through it, understanding what it's going to take to get there and what it involves and kind of how you grow and what kinds of things to expect at various stages. And of course everything's a little different for each person, but the same basic outline of how you go from learning your first game or doing something that inspires you to want to get into programming to becoming a software developer at a company as your job. That's a pretty similar path amongst a lot of people. They have small variations, but it tends to be almost the same for many
Yep.
people. And so this guy's defined that pretty well and given some guidance and some help for people who are on that path.
Yeah, yeah. I read it, and I thought it was like you said, very tongue in cheek, but is a lot of it is really true. I mean, some of it, like writing your own programming language, creating your own language,
Yeah.
that really kind of puts things in perspective. I mean, I feel like I agree that kind of everyone should do that at some point.
hmm
Just make some simple language that all it does is, let's say you can pass it some new operations. Like you make a plus plus. So one plus plus two is something else. Like I don't know, maybe it adds two twice. I don't know. Something it doesn't have to be useful, but just the experience of going through and writing a parser and a lexer and then actually writing the interpreter and things like that is extremely useful.
Definitely, definitely.
So yeah, part of becoming a good programmer is being able to sort of work magic. Take things that were meant to be in one environment and bring them to a completely different environment. And Google Native Client kind of does this, where it can take programs that were meant to be, on your desktop and bring them to the web, actually put them inside of a browser. And it's quite amazing how it works. But this news article kind of talks about one specific application where this guy has taken DOSBox, which is a DOS emulator, and ported it to Google Native Client. So what you end up with is if you're using a recent enough version of Chrome, you can actually have a DOS operating system in your browser. And he uses this to actually let you play DOS games in the browser. So he's created like this MS-DOS file system like on his server, I guess. And you can load up different games. So he's got like Falcon 3.0 and TIE Fighter and
Oh man.
X-Wing and yeah, he's got all these awesome old school DOS games, and you just literally just go to the website as long as you're using Chrome, and it's right there, and you just start playing. It's pretty amazing, and it really kind of showcases the power of Google Native Client.
No, I want to do this right now since I'm in Chrome.
Yeah, it's totally awesome. I played a little bit of TIE Fighter. To not get in trouble or anything like that, he only has the demo. I don't even know how he got his hands on the demo of TIE Fighter. He must have just had it from way back. But so you only can play the first level, but it's still pretty amazing. And I think, as part of the port, I mean, you should be able to just run anything you want. Like I don't know the details, but it's a complete DOS operating system. So
Yeah.
if you have your own TIE Fighter, you should be able to bring it to the table, I think. But either way, it's really freaking
That sounds
cool.
awesome.
And yeah, you guys should check it out.
Is it that
So
time?
now, I think it's time for
Tool
Tool
of the
of the
Bye
Bye
Week.
Week.
All right, what do you got? Let me guess. Hang on. Is it related to what we just talked about?
It's no.
Oh.
It's actually Google Native Client. What a twist! Yeah, so my tool of the bye week is Google Native Client. I've been messing around with this, and some of you might know I do a lot of work on MAME. I'm the creator of MAME Hub, which is, well, for people who don't know, MAME is an acronym and it stands for Multiple Arcade Machine Emulator. But now it's grown to cover like almost every arcade machine ever made and many modern consoles, or not modern, many retro consoles like NES, SNES, and all that. So this is sort of like the one emulator to rule them all. And been doing a lot of development on MAME, and I'm the creator of MAME Hub, which lets you play MAME games online. So like you could play like Super Mario Brothers online with someone in England or
You
something.
legally own it.
That's right, as long as you legally own the cartridge
Yes.
in your house.
Yes.
And yeah, if you want, if you're in the Bay Area, you can borrow one from me. I think I still have all my Nintendo games somewhere. Anyway, so I've been using Native Client for, been porting MAME to it and things like that. I've been really into it, and it's just, creating some sample apps in it. I can really see there's tremendous potential in this tool chain. It's just amazing. I mean, imagine you take something that you wrote maybe in high school or in college, or maybe it's an open source app that you really like, and as long as you can get it to compile in using this native client, it runs in the browser. I mean, it's a website, and so you can make changes, and anyone who visits your website automatically gets the latest version. You don't have to worry about deployment or anything like that anymore. It lets you do awesome stuff like immediately get people signed in. You can sort of it has a JavaScript wrapper around your code, so you can do cool things like make AJAX requests to some web server, and so you could do all the cool web things like tap into different web services like the weather and things like that, and tie all that into your desktop application really easily. So it's awesome. It's getting more and more popular. There's, like I mentioned in the news section, there's some really cool demos, and yeah, I'm a big fan. So I like to see what kind of cool stuff people make with it.
Very cool.
So Patrick,
Very
what's
nice.
your tool of the bye week?
My tool of the bye week is Handbrake, which is an open source transcoding application, and it's available
Interesting.
for Mac, Windows, and I think Linux as well. But the big one is originally it was OS. It was for the Mac OS, and then they've come out with versions for the others as well. And what this allows you to do is it's really easy for putting videos that you have permission to on your transcoding them so that they will play on your iPhone, iPad, Android device. So
Oh, interesting. So you can take a DVD, like you can take like your wedding DVD or something,
Yes.
and port it to your phone.
Yeah. So if you had a DVD of your wedding and you wanted to watch that on your tablet, then you would use this to convert it, because the tablets and phones, although they will often play different videos, like many different kinds of videos, they're typically optimized for a certain resolution, the screen size, and then also for a certain set of encoding parameters, because of the fact that they have hardware acceleration to do, for instance, H.264 decoding. So if you put it in that format, it's going to perform a lot better, or maybe not perform at all if it's not right. And what the nice thing about Handbrake is that it has all of those presets in there. So you can just say, I want this file encoded as for an iPod Touch 3G or 3rd gen. And so it'll do that. Or an iPhone 4, and it'll know how to do it. Or I want it for an iPad. And it'll go ahead and choose the right width or height and ratio for you, and also what encoding parameters to use, what bit rates to use. Those things that whenever you open up a video encoding thing and go, I don't even know what to choose here, can I please get some like auto button? It kind of has for you. And so you can just say what device you want to encode for, and it'll just kind of already have the presets in there.
Oh, that's really awesome. That is a fantastic tool. I've never seen this tool before.
Oh, no?
I'm definitely going to use it.
Yeah. And it supports a wide range of inputs. So it's pretty nice. It's just one of those things where it almost always works, and that's nice. It's nice to have a tool where it's not like you got to have 15 different things to be able to do one task.
Yeah, it's pretty. And this really sort of sets a precedent now that you've used an open source tool and not um,
Yes.
as your tool of the bye week.
Yeah, this is the first time in a while. I've been doing closed source tools for the last few episodes, and yeah, I'm back on the try to do open source, not just free. We haven't done
Nice.
any paid tools yet, though, so
Yeah, I don't think so. I think you're right that we've never done a paid tool. That's because there's no paid tools that are any good.
I won't say that. You may say that, sir. I won't say that. There
I'm
are
just kidding.
certain people who want to charge for their applications often have very good reasons for doing so, and they are more than entitled to try that.
Fair enough.
So, okay. Enough philosophy. Time for the discussion of our programming language of the week, Lisp.
That's right. Lisp is the language we're going to be talking about. It's really interesting. It's definitely if you're into computer science and sort of the understanding like the history and sort of the more I guess the less hands-on, the more kind of pie in the sky theory and things like that. This is a good language to know. It was actually invented before it was implemented. So someone, and do we have the person's name? Let me see. John McCarthy, back in 1958. So this was a very old language. He kind of formalized this idea of Lisp and sort of the core functions that constitute the Lisp language, and sort of proved that Lisp is Turing complete and things like that. Before there was even an implementation. I mean, this was just all done in paper. It was a thought experiment, right? And it wasn't until much later, actually, I guess a few years later, that Steve Russell created the first Lisp implementation. So, yeah, so Lisp has a wide history. Because Lisp is so tied to computer science, there's just tons of different dialects of Lisp. There's
It seems to
scheme and
be
things like that.
it seems to be probably the how do you say it's like the most well-known, least used programming language. Like people use
Yep.
it, but not every day. Like people don't use it in their everyday jobs. But it seems like everybody who goes through computer science learns it, or even people who are just interested in computer programming will pick it up and they'll at least play with it, if not learn to be experts in it. At least know it, but then not use it.
Yeah, that's right. Yeah, and I think part of the problems with Lisp, and we'll talk about this more in the weaknesses, but is that it's so fragmented, right? I mean, this isn't really a problem with Lisp as much as just I guess the social sort of just the events that transpired. But Lisp is so fragmented. There's many different compilers for Lisp or interpreters, I should say, and there's so many different dialects. And for a long time, none of the interpreters were open source. So each one sort of had its own nuances, and
Hmm.
and so I feel like this has really kind of plagued Lisp. But the two things that are sort of critical to Lisp are car and cooter. So CAR and CDR. And the way this works is think of everything in Lisp as being a pair, and the pair is actually called cons, C-O-N-S. So you have a pair of objects, but the objects themselves they could be anything. And to go from a pair to the specific like elements in the pair, like the first and the second, you'd call car to get at the first, or you'd call cooter to get at the second. And so just with cons, car, and cooter, that forms the basis for the entire Lisp language. It's a lot of it's based on lambda calculus, which gets into some pretty heavy stuff. Basically, lambda calculus is sort of a formalism. We talked about first order predicate calculus. We were talking about Prolog. And so this is just another way of sort of representing numbers and the computations on those numbers. And you can read about it more on Wikipedia, but understand that similar to Prolog, Lisp is sort of based on calculus. And so because of that, you can imagine it's not something you're going to write device drivers for, right? So this is something that's kind of very theoretical. However, there have been Lisp machines, Have you heard anything about this?
Yeah, yeah. Well, it was a little bit before my time, I guess. Although maybe I was still quite young when some of it was going on. But the Lisp machines was kind of an effort when the personal computers were first coming out to have a machine that was for individual users, which although didn't directly implement Lisp, so there weren't assembly level commands that said, the parts of the Lisp language directly. What it did was provide a really simple stack-based processor as opposed to a register-based processor, which I guess gets pretty in-depth and probably outside the scope for this discussion. But instead of register-based, it was stack-based, and the commands themselves were meant to be very easily derived by Lisp code. So it was Lisp code would translate into very few instructions, as opposed to on a normal register-based CPU, for instance, a single Lisp command may take many machine instructions to implement. And so this processor architecture was put together in something called a Lisp machine that was meant to be easily programmed and efficient at writing and using and running Lisp programs.
Right. So I mean, think about the difference between, say, C and Lisp. So in C, just from a data perspective, in C you're dealing with arrays and pointers that point to different spots of memory. And so you do pointer arithmetic. So for example, if you have an array and you want to loop through the array, um, you would have a pointer at the beginning of the array, and then you would sort of increment. It's very numerical. You just say, I want to push my pointer a little bit further and read the data over here, and then push it further, kind of like you'd read off a tape or a record or something like that. Um, in Lisp, you don't have arrays. What you have are, as I
Lists.
mentioned, these pairs. Yeah, so you have pairs. So if you want to have, say, a list, if you want to have an array, let's say in Lisp, then what you would have is you'd have a pair. The first element in the pair would have some item in your list. Let's say it's a list of numbers. So the first element in your pair would have the number, say 4. And the second element of your pair would have a pair in it. And then that pair, the first element would have a number, let's say 2. And the second element would have another pair. So you see, everything is done in pairs, and any of the two elements in the pair can be either an atom, which is a number or a word, or something that's immutable, something that can't change, like a constant, right? Or it's either a constant, or it's another pair, or it's nil. Those are your three. Those are the only three,
Mm-hmm.
things that can exist. So as we mentioned in JavaScript, where there was only four things, in JavaScript there's nil, array, object, and literal. In Lisp, there's only atom, which is the same as literal, pair, and nil. There's only three. So, you would think that because it's so simple that, oh, it must be like really low level, like you must use this for drivers because it's such a simple language. But actually making the language very simple is really what gives it the power and gives it the ability to represent incredibly complex things. And I'll talk about this a little more when we get to the strengths. But understand that, a regular machine that just has a bank of memory where you can just do malloc and get arrays, that kind of machine doesn't run Lisp very efficiently, especially, 30 years ago, 40 years ago. So the idea of the Lisp machine was, let's make a machine with the constraints of Lisp in mind. Let's make a
Mm-hmm.
machine that deals with things in terms of pairs.
Right. And I mean, it seems like they were fairly successful at doing that. It was just that the competition and the market was somewhere else. It was in the traditional register-based machines running C. And
Yeah.
so it seems like there have been many of these instances in the even short-lived software world where even if something made sense or was technically superior, it won out. Something else won out because of just market inertia or happenstance or various other things. And the Lisp machine kind of fits in that category.
Yep. Yeah, I'd like to think that, being an AI person and being sympathetic to Lisp, I like to think that it's sort of the grandfather of many other languages. Like, other languages like Python, JavaScript, which is based on JavaScript was based on Scheme, right? It was
It's
inspired by
influenced. Yeah,
Scheme.
yeah, yeah.
Yeah, and Scheme is a dialect of Lisp, so there you go. And even MATLAB, which is now very popular. Uh, you know, Lisp is sort of the grandfather of all interpreted languages, and is a good source of sort of inspiration for languages that came after and offered much more boosts in productivity. Without all the hindrances that Lisp has.
Yeah.
Yeah. So, um, yes, as we mentioned, has many dialects. But one of the reasons why there's so many dialects is because it's really easy to write an interpreter or a compiler for Lisp. In fact, as we mentioned with the become a good programmer in 6 really hard steps. The author even mentions that, hey, you should write a Lisp interpreter as your language, because it's a good
Yeah,
starter.
there's so few things you actually. Well, I mean, it seems tricky at the start. It seems so easy to get started because there's so few things you have to implement.
Yeah, and keep in mind that, and this is true for all languages. I don't know if we've mentioned this before, but most languages are written in themselves. So, and we have talked about this where, we talked about Python being batteries included, where there's a huge corpus of tools that you have that are available to you when you start programming. The vast majority of those tools are written in Python. This is true even of, C and Lisp and other languages, just to a lesser extent. So, 99% of Lisp is written in Lisp. And, if you could take like the common Lisp libraries and use your own interpreter, you could really have your own Lisp like fully featured interpreter in a day. I mean, of course, it wouldn't be fast. It'd be nothing like C Lisp, but it still would be fun. It's a toy to play with.
And it seems like the other thing is that there are a lot of people who take Lisp and use it as kind of a intermediate language where you write something in Lisp and then you compile. Like we talked about people doing this to JavaScript before, but people kind of use Lisp as an input language to the compiler, I guess, and then compile it to some other form of a language. So there's Clojure, which is Clojure, as opposed to we talked a little bit about the Clojure kit tools last week or last
Yep.
episode, and that is implementing Lisp on top of Java. So using the Java virtual machine and using Lisp as kind of I guess what is that, the front end to it, and saying
Yeah, nice.
how do we do that, and it's got a lot of popularity, and there's also the everybody kind of has their own little ways about some of the finer nuances of the language, and so each of those tends to kind of get its own spin-out dialect, which initially starts out really close to the one it started from, but then slowly drifts away over time.
Yep. Yeah, so some of the strengths of Lisp. One of the strengths is that it has very, very efficient hash tables. And this is tied directly to the fact that there's so few data types. It does a lot of sort of like clever tricks with the pairs, and it can actually store a ton of data in a hash table very efficiently by sort of reusing the same data. Lisp is amazing at this.
Well, we
And
should
so you.
we should
Oh,
explain
go
what a
ahead.
hash table is.
Oh yeah, you've probably never done that. So yeah, so a hash table is something that essentially maps one data type to another. So,
One
yeah,
value.
yeah, I guess one value, maybe that's a better way of saying it. Essentially maps one value to another. So, for example, um, let's say you wanted to store the days of the week. So if you put in, 0, you got Monday. If you put in 1, you got Tuesday, right? So in C, you could just have an array. And at the array index 0, you would just hold the string, a pointer to the string Monday. And 1, you'd hold Tuesday, so on and so forth. And then you'd say, days, open bracket, 2 to get Wednesday, right? What if you wanted to go backwards? Like, what if someone gave you the string and you wanted to return what day of the week it was in numbers. So if someone gave you Monday, you wanted to return 0. So in this case, you'd have to use essentially a map, and the map would have to map strings to numbers. See, an array, you can think of an array as a map, which maps numbers to something else, whatever's in the array. But whenever you need to map something that isn't a number, let's say you need to map, a floating point number, or as I mentioned, a string, or maybe you need to map a chessboard, like the entire board, like a whole class with the pieces and where they are. You need to map that to a number. To do something like that, you have to use a map. And one very common map implementation of a map is a hash table. What a hash table does is it basically is based on the principle that you don't actually need the key. So in other words, I don't actually need to store the string Monday in this table. What I need is when I get the string Monday, I need to know to return 0. But that doesn't necessarily mean that I need to hold Monday in the table. So that sounds a little confusing, but take for example, let's say that your hash table, instead of storing the whole string, it just stored the first 2 letters. So that would be sufficient, right? If someone passed in Monday, then I would just take the first 2 letters, MO, and just look for that in the table. And that would return 0. And I've saved some data. I didn't have to store all of Monday. Now, I couldn't use one letter, because if I did, then Tuesday and Thursday would both map to the same location. That's called a collision. Right. And so there's ways to deal with that even, so it's not the end of the world. But, I could store 2 letters and save a lot of data. And so hash tables, there's a lot to it. If you're really good at hash tables are sort of the backbone of just about everything in computer science, especially distributed processing or, web and stuff like that. So it would take a whole show, but in a nutshell, Lisp and the way Lisp works, the objects in Lisp are very hash friendly. And on top of that, Lisp can do a lot of object reuse. So it can implement hash tables very efficiently, very quickly. It can implement them without using a lot of memory. And this is really important for the applications, which we'll talk about later.
Mm-hmm.
So do you have any other strengths for Lisp?
Yeah, so one thing that, well, I guess this is one of those, it could be a strength and could be a weakness, is that you can use Lisp to parse itself. So the difference between data and instructions in a C++, Java, Python program is very clear. It's very much, here's my code and here's the data I'm storing. I'm assigning this data to this variable. And only in a few kind of edge cases where you might talk about function pointers or some kind of obscure things where your variable stores a pointer to code or code somewhere. But that isn't the usual case. It doesn't normally happen. But in Lisp, you can have your program is represented as these pairs. So you can this very easy to intermix both the data and the program, and that means that you can manipulate the program. So that's known as self-modification. So when the code as it's running changes the code that's running. And in Lisp, this is easy to do because like I said, there's no real distinction between data and the program. And that's a strength. There's some really powerful techniques that you can do and that make really efficient code. It also happens to be something that can be very hard to understand, but it's one of those, with great power comes great responsibility. If you use it wisely, right, it can be very powerful. And if you use it poorly, it can cause problems. But Lisp is really good at doing that.
Look at like the roguelike, for example. So let's say you're making a simple roguelike game following the 15 steps. And you make a sword, and you have this sword class, and you have some data, like you have the great sword, where the name is great, and it does like 10 damage. And then you have like the awesome sword. So you have some text file, and the text file just has, great sword, comma 10, awesome sword, comma 20, light sword, comma 30. And so like then you write some C program that looks at your text file and then says, okay, create, and then create a great sword, create an awesome sword, and then put these in somewhere in memory so that I can fill my world full of great and awesome swords. But what if I wanted a flaming sword, and when you hit somebody with it, they caught on fire, and there was all this code and stuff like that? Well, that can't really go in the text file. I mean,
You can't
like how
describe the
would
flames.
yeah, you can't describe the flames and the effect and the person catching on fire and what that means. All that logic. You can't just put that in the text file. I mean, you'd have to put it in the C file and then know that, oh, a flaming sword has this, right? But with Lisp, you can just, your data and your code is the same thing. So you'd have, in Lisp, you would have, a pair. And the pair, the first element would be the name, and the second element would be a pair, which would have the, a damage. And then, the third element there could be an entire
Code.
Lisp program, which is what happens when you hit someone with the sword. And you don't have to worry about reading your data from the text file like you do in C and like, creating sword objects based on the data in the text file. You just load that Lisp file and it's done. So yeah, you could do some awesome stuff with it. But yeah, I mean, it makes it very difficult to debug and things like that. So
Yeah.
it's kind of a wild thing that you have at your fingertips.
So with all of these things are nice features. The everything's a pair, and there's the language provides some abstraction. So I guess we should say that even though everything under the hood is a pair, the languages allow you to not have to literally, if you want to make a list, have a pair where the second element is another pair and the second element is another is another pair. They give you the power to just make one long list and do that pairing for you.
Yeah, that's a good point.
So yeah, I was just thinking about that because one of the weaknesses, though, that even with that, Lisp tends to have a ton of parentheses, and parentheses are what are used to kind of wrap each pair.
Yeah, I mean they've done a lot to make it less painful. So as Patrick mentioned, if you have 10 items, you can just put a single parentheses around them, and Lisp under the hood knows that it's like a bunch of pairs that are all chained together. But the fact is, yeah, I mean, you're dealing with pairs, and as you might imagine, there's a lot of data, a lot of variables you might have in your code. You're going to have a ton of parentheses. That's kind of endemic of Lisp programs. So, fortunately, if you use Emacs, you can it'll match up or actually, I guess most modern, or not even modern, most editors will do this for you, but it'll help you match up the parentheses. But yeah, it still can make things a little cumbersome.
Yeah, it's not really a weakness, but it is something when people look at Lisp code. Some languages you don't exactly know at first, like C++ and Java. Sometimes you have to kind of look at certain lines of code to kind of understand what it is. When you look at Lisp code, it's really easy to tell because you just look for all the parentheses.
Yeah, I mean, think about this. As we mentioned again, everything's a pair. So if you want to add two numbers, what you really want, you want a pair of a plus sign and a pair of a 2 and a 3 underneath it. So you have now with C Lisp and more advanced Lisp, you can take away the parentheses around the 2 and the 3. But you're going to have a parentheses and then the plus sign and then 2 and 3. That's another thing about Lisp is that everything is in prefix notation. So if you want to do 2 plus 3, you actually want to do plus 2, 3. And so because it's in prefix, let's say you wanted to do 2 plus 3 minus 4. It would actually be plus minus 2, 3, 4. So now that doesn't make any sense, right? Because the order of operations, you don't really know. Prefix notation doesn't really give you order of operations. So to deal with all that, you specify the order explicitly. So to do 2 plus 3 minus 4, you'd actually do open parentheses, minus sign, or
I think you said
minus
that.
sign, open parentheses, plus sign 2, 3, close parentheses, 4, close parentheses.
Yeah.
So just to do something that simple, you already needed 4 parentheses, like 2 opening and 2 closing. So It can get pretty cumbersome. But one of the other, weaknesses of Lisp beyond just the syntax is that it doesn't have direct memory access and doesn't really have much in the way of hardware access. So people have written extensions, but for the most part, it's not really designed to fit the model of a computer. And this is one of the things that really hurt Lisp, and that's what inspired people to make the Lisp machines that they did 20, 30 years ago.
Yeah, and that's
Um,
really fundamental, being able to manipulate specific memory locations, because that's for people who've never done it before, it may not be obvious, but that's how at the lowest level all the drivers work. So the things that control hardware all come down to basically putting certain values at certain memory locations. And
right.
doing that causes something to happen electrically on that peripheral device. And that's how device drivers are written. And so if you don't have the ability to control exactly what the contents of a certain memory location are, then you're not going to be able to control that device. And you can't write device drivers. And that's what a lot of low-level code is, working with those kinds of things.
Yeah, I mean, a lot of people are probably too young. A lot of people listening to the show are too young to have serial mouse. But when I started learning about computers, I had a serial mouse, and what that was the plug for the mouse had, how much does a serial port have? Like 8 pins, I think,
9.
or 16? Has nine
DB9.
pins?
Yeah.
Really, nine? That's a weird
For a
number. Anyways,
mouse? No, or just a regular serial port.
no, this isn't a PS2. This is like an old serial mouse,
I think it
like
was
with
even
the
before
serial
my
port.
time. But then, yeah, then that was 9 pins.
Okay, yeah. So just think of that. It has 9 pins, and it naturally fits an array. If you want the eighth pin, then you call array index 7, right? So I mean, the way that computers are architected and built, the way memory is laid out, all of these things sort of fit the linear, C model. And back when it was really important, when speed was really important before computers got as fast as they were, and when storage was really important before hard drives got as cheap as they are now. Um, languages like C just completely dominated, and only now are people starting to leverage more like productivity-focused languages like Python. But Lisp was really sort of only useful to academics at the time when it was most popular.
So you already kind of mentioned that Lisp is used a lot in the artificial intelligence community. What kinds of things do you guys use it for?
Yeah, so Lisp was used a lot in planning, and so let me explain a little bit of what planning is. Planning is basically searching through like a particular space and figuring out sort of what are the optimal actions to take. So, for example, path planning is, let's say you have, again, let's say you're making a roguelike game and you have this grid world, sort of like where the whole world is just a grid of numbers. You're at coordinate X, you're at coordinate 3 comma 5, and then you take a step to the left, now you're at coordinate 4 comma 5. It's very discrete, right? And so, you want to navigate through some maze in this grid world. What you want to do is to plan. You want to sort of try all the possible moves you can make and then see where you are. Are you closer to the goal? Are you further away from the goal? Like, what's the state of the world after these different actions I could take?
Hmm.
So, again, going back to Lisp's strengths, right? You can create a hash table where the key is the entire world, the state of the world as it is. So in this grid world, the key might be just your position, and the value would be, how close you are to the goal. Or maybe even just you want the hash table to store as a key the state of the world and as a value whether you've seen this state or not. So if I take a step to the left, that's a new state. So I'll put that in the hash table. And then let's say I try taking a step to the right. Well, that puts me in the same state I started at. So I go to my hash table, I say, hey, here's some new world I discovered. This is the world where I'm at coordinate 4 comma 5. And the hash table says, no, you've already been here before. Like, don't bother trying to go further. Like you've already tried all the actions when you're at 4 comma 5. And so doing this will keep you from just going left, right, left, right, left, right. So eventually you'll explore all of the possible game states, all the possible world states until you get to the state where you're at the goal. Um, Now to take it to the next level, the hash table could not only say whether you've been at that state before, but it could say how you got there. So, once you get to the goal, you can say, okay, this state of the world that I visited or that I'm at now, how did I get here? Check the hash table. The hash table will say, oh, you got here by making a move to the right. So you could do the opposite, backtrack, right? Make a move to the left and say, this state of the world, how did I get here? And it could say, oh, you got here by moving down, so on and so forth. So this is planning. And to do effective planning, you need good heuristics, which that's just simple algebra. So you can do heuristics in any language. But you need an awesome hash table. And Lisp definitely gives you that. So it's very useful for planning. Expert systems, it was also good at this. This is kind of a buzzword. Expert systems is basically planning, but instead of planning over something very discrete, like as we mentioned, planning through a grid world or something like that, in the case of expert systems, you're planning over rules. So this is similar to Prolog. Actually, this is almost exactly Prolog, but at a
Yeah.
lower level, yeah. So, in the case of Prolog, it's this really high level abstract language where you're specifying these rules. In the case of Lisp, sort of, you would be creating the Prolog interpreter essentially in Lisp. But you could also do other low level things. Like you could have rules that were mathematically based. You do things like that. And so a mathematically based rule system which parsed natural language, it basically tokenized the languages, tokenized the text into syllables, and then based on the syllables, tried to get an understanding for the language, like where the noun is in the sentence, where the verb is. There's a system that did this called Shrdlu, Shrdlu, and it really made Lisp famous. So what this guy did, he was able to scan an entire encyclopedia, and then for each sentence, he was able to figure out where the noun, the verb, the object of the preposition, all the different parts of speech for that sentence. And then he created a hash table for each sentence where the key was I believe the key was the verb and the value was the noun, something like that. But basically, because he scanned the entire encyclopedia, you could ask it questions like, how many toes or how many legs does a zebra have? And it actually could tell you answers in English. So you would literally type in how many legs does a zebra have, and it would answer you a zebra has 4 legs in English. And this blew people's mind, right? When this program came out, people thought, okay, we're going to get a human robot in the next 5 years. Now, this program came out like in the 60s, right? Or maybe not that late, maybe like the 70s. But I mean, it shocked, like it rocked the AI
Hmm.
community, and it was done by Lisp, and it really made Lisp very popular at the time.
Another thing that people use Lisp for, and you talked about it a little before, but Emacs.
Yep.
You mentioned that it'll help you do the parentheses matching, which a lot of editors will do, but Emacs uses a version of Lisp as a way to do its extending the Emacs editor. So the Emacs is one of the I don't even want to say anything because it'll just start a flame war. But Emacs is one of the editors that is popular on the Linux platform,
I'll
and
say it.
it is able.
Emacs is the best editor for the Linux platform, and also
All right,
the only thing that might be better is Xemacs.
I'm not going to say anything because I want to not have my email inbox completely filled
I,
with people writing in about this.
yeah, I have a feeling the guy who sits at the stand-up desk will be kicking my ass tomorrow.
Oh,
And he has a very
so
strong
but
leg because he's been standing on it all
he's
day.
just standing the whole time. Well, no, he'll rest on the chair first, the leaning chair,
Yeah,
for a few minutes,
that's right.
and then he'll.
And then he'll kick me
Um,
down.
so Emacs allows you the option to add functionality and increase its abilities by writing in a form of Lisp in one of the Lisp dialects,
Right.
and that's a very popular use of the Lisp language.
Yeah, definitely. Also, I guess it's what's the ITA stand for? It's like
I
International
don't know what
Traffic.
ITA stands for, but Google now owns them. But they were kind of, yeah, like the big back end infrastructure servers for, they're like all of the major internet travel websites, like Orbit, Travelocity, that went and queried a system for tickets, information, flight paths, times, on time percentages, those kinds of things. These people like tracked all of that data. They were like the people who all these websites use to get that information from, and all of their software was written in Lisp.
Yeah, that's right. So I think they've probably been around for a long time, and
Yes, yeah.
they probably when they were around, other languages like Python and things like that probably weren't that popular, or maybe even didn't exist. And so they were, had the foresight to jump on a productivity-based, productivity-focused language like Lisp. And so it's carried them all the way to today. So definitely Lisp has been used in enterprise solutions. Another more academic application of Lisp that was very popular again at the time was Maxima, which is a computer algebra system. So, algebra really is a planning problem, especially at a higher level. Like, you think about it, you have an equation. Let's say you have, let's say a simple equation, like you have, 4 divided by 2 plus 3, and you just want to know the answer to that. So, you have to do planning. In this case, you only have one thing you can do, which is the division because of order of operations. So you divide the 4 by the 2, that's your one action. Now you're into a new state where you have 2 plus 3. Then you take another action where you combine those and you get 5. But as you get to more advanced things, especially like integrals where there's many different rules you can use, or derivatives, or you get to differential equations where there's 10, if not 15 or 20 different ways you can solve a particular ODE, particular differential equation. So this thing does planning and says, all right, again, here's the state of the world. It's this differential equation. Let's put it in a hash table, and then let's start trying different rules, different ODE, different differential equation solvers, and it can it can sort of try these rules, and by enacting these rules on the equation, it creates a new equation, and that's a new entry in the hash table. And the hope is eventually it can reduce some really complex differential equation into something much simpler, or it can reduce some integral using some trig identity into something much simpler. So Maxima used planning to solve many computer algebra problems.
All right. Well, I think that wraps it up.
Yeah, so yeah, the uses were pretty cool. The Maxima computer algebra system, the ITA software, Emacs, AI. Has been used for some pretty awesome things, and it's also very interesting to learn. So definitely take a look at it and stay tuned.
Yeah, I've said this before, but Lisp is one of those languages where learning it, even if you don't use it in your day-to-day job or don't ever become super amazingly proficient at it, it's one of those things that'll help you become a better programmer.
Yeah, definitely. So if a couple of people have been adding us to on Google Plus, that's awesome. Definitely add us. We actually invited the anyone I knew from from my Programming Throwdown circle. We invited to the Hangout. So definitely, can take some of your questions and your feedback directly when we do the shows and things like that, which would be awesome. So
You'll have to
definitely
try that
add us,
out,
but
see how that goes.
yeah, yeah. But shoot us an email. So add my name on Plus is jgmath2000 at gmail.com. And I think you're P. Wheeler, right?
Patrick LW.
Oh, sorry. PatrickLW at gmail.com is Patrick. Shoot us an email, before you add us to your circles, so that we know that you're in Programming Throwdown, and we know kind of that you're not some spam bot or something like that. Although, spam really has been brought to quite a minimum on G+,
Yeah, I
which is
haven't
pretty
seen
cool.
too much of it.
But yeah, just in case, shoot us an email, let us know. Give us some love.
Yeah, for all of you who have added me, I know some people have, and I haven't added you back. I'm working out a system. I'm trying to keep my stream with people that like I'm really trying to pay attention to, and I still haven't figured out how to add people and then not, have them flood out my normal stream. But I have been looking at what you write on my incoming stream, so don't feel like that I'm being mean to you.
Yeah, definitely. I'm gonna keep inviting anyone in my programming throwdown circle to the hangout before you record. So if you have any feedback you want to add, or if you have any questions, or if you have a language, we'll do an impromptu language. I'll throw down the gauntlet right now and say that if someone has the right timing to jump into our hangout while we're recording the podcast, we will do whatever language they want
Well, I will,
on the
I will, I
fly.
will make it that if they are willing to come on the podcast, if we don't know anything about it, and do at least part of the spiel of it.
Yeah, that's true. We need some help. If someone comes in and says, "Oh, I want you to do Motorola assembly at buy," I mean, then we can't. We're kind of stuck, right? Um, or I want you to do M68K, Donkey Kong assembly or something. But but yeah, you definitely have to be willing to help us out, because we're going to be floundering a little bit. But I will throw down the gauntlet now and say we'll do any language someone wants if they jump in the hangout
Jason
and
might
tell
be
us.
doing it by himself.
But yeah, shoot us an email, let us know so that we know who you are, um, yes, that would be awesome. And definitely check out the blog,
And
programmingthrowdown.blogspot.com.
our email address is programmingthrowdown@gmail.com.
Yeah, that's right. So I guess until 2 weeks from now, have a good one, stay safe, and learn use some Lisp for great good.
All right, take care.
See ya. The intro music is AXO by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share Alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, and adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.